So if we follow this question, what we're being asked to find is the mass of zinc in the coin. Okay, so what is our given information? We are told that we have a penny that weighs 2.507 grams. That penny is composed of zinc and copper. And then we are also told that that penny is 97.5% zinc. Well, if we take what that 95% means, 97.5 per 100, that's our percent. This is in reference to zinc per wherever it came from, in this case, the penny. The measurement unit for these, it is very commonly, in fact, so common that it's typically not written, but when we're looking at percentages, they're almost always by mass, particularly if they're for solids. So this would be 97.5 grams of zinc in 100 grams of penny. Why does this become useful to us? We're being asked to solve for the mass of zinc. Okay, we now have a measurement unit, mass being grams of zinc, appearing. So if we folded this out into the unit system that we followed before, we want grams of zinc in our answer. We know we have 97.5 grams of zinc in 100 grams of penny. I know I don't want grams of penny, so I'm going to have to introduce grams of penny here. And my given information about the grams of penny was told that it is 2.507 grams of penny over 1. All I got to do is do the math now. 2.507 times 97.5 divided by 100. That is roughly the entire mass, so we're effectively multiplying by 1, which means the number should be darn close to 2.507, which means B should be wrong, C should be wrong, and E should be wrong. If I could do math in my head better, I might actually be able to spit out what that answer was. Looks like my son ran away with the calculator, which makes this a little bit harder because I'd actually have to solve that out. If my phone will work, maybe get 2.507 times, what did I say, 97.5? And we get 2.44 grams. Officially, we get a little bit more than that with sig figs and all that fun stuff. Thankfully, we don't have to worry about sig figs in this case. This is a question where sig figs become irrelevant because all of our answers here have the same number of sig figs. They all have 3 sig figs. So we didn't have to stress about that within this particular question. Because I can't see, because I can't see the comment screen, I was going to pause the video in case you wanted to chime in and discuss something that was written down. Reaction. One thing that we could go through and do is identify or know what our pattern was for a neutralization reaction. And if we go back and look up that pattern, it's HA plus BOH gives us H2O plus BA. So that's our general pattern. So if we go through, and I'm going to have to rewrite this one down below, HNO3, BaOH2, and we're trying to match that to our pattern, well, we've got our H, A, and then we have our B and our OH. So if we're following that, we'll end up with H2O, which I'm going to write as HOH, and we'll see why here in a second. I'll write H2O above. And then plus our B and our A. So the default in how we organize things is that our cation goes first, which is typically a metal, in this case Ba. We'd get Ba and then NO3. Before we get too excited about trying to go through and find an answer, we need to make sure that the products that we've predicted here are correct. And what I mean by that is we have to go through and evaluate our charges. When we looked at the H, it's a +1, and our OH is a -1, which means those would come together and balance out. So H2O was a correct formula. If we'd memorized the pattern, we already knew that, so that was okay, because that's an actual compound. The pattern of Ba isn't a balanced thing because we don't know the identity of the elements, B or A in this case. So if we go through and now look at the barium with the nitrate, barium is a +2, and we would know that because it's in the second column of the periodic table. Or we go back to our starting material, hydroxide's a -1. There were 2 of them, which means the barium had to come in as a +2 to balance that out. Nitrate is a complex ion that we are supposed to have memorized the charge on. -1. Again, if we decided that we didn't know how to do that, we know hydrogen's a +1. Our nitrate had to come in as a -1 to balance that charge out. What does that mean for us? Our charges don't balance. We need 2 nitrates to balance the barium, so I need that extra 2 to balance the charges. Okay. In this case, we aren't being asked to balance the equation. We just need to know what the products are. So where I was all talking about balancing the equation, we didn't need to do that. So we know we have H2O or HOH, and we have our barium nitrate, BaNO3 If we go through and look at our answer choices, hopefully you'll notice that the H2O shows up in a bunch of different locations, and D and E we could eliminate. So if we'd memorized that neutralizations produce water, we got rid of 2 of our answer choices, which is good. The next part is deciding what would be remaining after that. This is where if you know the full process, you've got it solved, as we just went through and did. If you don't know the full process, it becomes a little bit trickier to detail out. Okay, so let's say, just for giggles, the only thing you remembered was the H2O. Well, what you should try and do is backtrack out of that you've now explained away the OH and you've explained away the H. Because of that, you now need to explain where the Ba and the NO3 ended up. Okay, so you'd have to somehow bring those together in the end. With that information, we could get rid of B, because that was Ba3N2. Where did we destroyed nitrate? That doesn't match any of the patterns that make sense to us. And we could also actually get rid of A, because that shows NO2. Okay, so nitrite, not nitrate. I would argue that this question was poorly written, and there should have been another answer choice. Okay, and for those of you at home that might be able to predict that, I think there should have been another answer that was BaNO3 and H2O. Because that's now going to address, do you actually understand that when you predict your products, you have to have them balanced properly? Okay. The problem with doing that is that now makes it a bit misleading, and you see BaNO3 show up now in multiple cases, and that starts to suggest that that's a correct answer. And so you could start to reason through, by process of elimination, through testing strategies. Okay, so what I'm going to do is pause the recording on that.